Hello, this is our ELG to 2336 coffee monitor project by Jason Sousa, Caputo, and Ronald Medeiros. So you can see this is the main structure of our project where we have a fan at the top which is connected by screws onto the main structure. Cables coming down onto the side. We also have our LED or temperature sensor table. We have our hot plate here, which is heated by toaster oven coils, which is put right in the middle of the structure, like that. We have our fan, which is connected to our main circuit board, where we have a bright LED light, a blue LED light, and a red LED light. Each purpose will be discussed later on. We have 2 relays, a couple resistors, and our output and input. And we have our Labjack, which is connected onto the computer, and we have a program running which will control the temperature of the system.
So like we mentioned, this is our circuit and this is the software that we have, and as you can see, it's a real-time data acquisition software, and it's connected to our Labjack. This is our microcontroller, and as you can see, it has our different pins that navigate between digital outs, digital ins, and analog ins. And as you can see, this is our LM35, which actually monitors temperature, and right now it's connected into the microcontroller via USB, and that is what the data acquisition software analyzes, whether it be the LEDs, the analogs, or the different components. So if you can see, I can hold on to the LM35 and you will see a spike in the temperature as it increases. This is what we're going to be using to monitor the different things, like the coffee cup, and as soon as I let go, you'll see that it'll start to decrease in real time. So like we were mentioning, our circuit board has a few things like the LEDs that monitors the temperatures. It has the relays that will switch between our fan and our heater. It also has the transistors, which will amplify the current and the voltage that comes in and out of the circuit. And the software is what's going to use everything to output the different things, like the LED color will monitor the different temperature, and it will switch with the relays between the heater if the coffee cup is too cold, and it'll switch on the fan if the coffee cup is too hot.
So at the moment, our mechanism is actually recording room temperature, as you can see from the chart. So our temperature is below at 33 degrees, which is what we consider hot temperature. So now we have a hot cup of water, and we're going to put it right here in the temperature sensor. And you can see from the chart that the temperature will spike up, and that will be turning the red LED on, and then therefore the fan will turn on, as you can see on the video. It will cool down the temperature, and then the bright light will turn on. Stop. All right.
So what we're going to do now is we're going to put a hot cup of water and we're going to see how it actually monitors the temperature. So as you can see on our software acquisition, it'll show right now that it's only measuring room temperature. So it's below 33 degrees. And as we've done tests on, we've realized that hot water, hot coffee stays drinkable around 31 to 33 degrees. And when it's over 33 degrees, it's way too hot. So what I'm going to do is I'm going to take this hot cup right now, I'm going to put it there, and it's going to start to measure the temperature. And as you can see, the temperature will start to increase. Right? Now, what you'll see is once it gets above 33 degrees, the red light will come on, and that red light will send a signal to the relay, and the relay will send a signal back to the Labjack, and that's going to turn on the fan. So now that the fan is going, you'll see that the temperature will slowly start to decrease, and you can see that by the software data acquisition. Now, as you see, when it gets to a drinkable temperature, which is between 31 and 33 degrees, you'll see that the bright light comes on. Now, give it a bit of time because that light will start to, there it is. So that bright light is what's going to mention, with the fan turning off, that it is drinkable. Now, a little more time is going to go on, and that drinkable water will slowly start to get colder and colder. Once it gets colder and colder, you'll notice that the blue light goes on. That's when it's below 31 degrees Celsius. And you'll notice that as well by the data acquisition. It's starting to get colder and colder.
So as mentioned before, our drinking temperature is now below 31 degrees, which will turn the blue light on, and this is going to send signal back to the Labjack, and the chart, as you can see, will start to rise again as our coals will turn on, and our temperature is now going to spike up to a drinkable temperature, which is between 31 and 33 degrees. Our coals are going to turn off, and our bright LED light, as you can see from the circuit, is going to turn on. And we'll mention that our liquid is now drinkable. And this is our ELG project, and I hope you liked it.